Welcome back to the class for orals DJ's Marine YouTube channel. Today we are going to discuss about the insulation resistance measurement with a Megger and what is the Megger. Please subscribe to this channel before proceeding further and please watch this video till end for the complete understanding of this insulation resistance because this is going to be very much important video and it contains animations to have better understanding and learn better. So let's proceed. There are some misconceptions regarding the insulation resistance definition among the people. Many people think that it is used to measure the resistance of the insulation. So far, this statement is not correct because we are not actually measuring the resistance of insulation. We are measuring the leakage current. Then indirectly we get to know about the resistance of insulation. And we all know that the leakage current, if it is very high, then IR value will be 0. And the leakage current, if it is very low, then IR value will be infinite. We will be discussing that what is the leakage current and how to measure the resistance of insulation in this video ahead. So please be in this video and make notes side by side. The actual meaning and definition of insulation resistance. In insulation resistance testing, the conduction or leakage current is the one that is giving us the information. There are faults in the windings and the cables and the wires like earthing, short circuiting, which can cause the large amount of the current to flow from high potential to the low potential, that is earth. Then because of the high current flowing, it can turn into the I2R losses, and then high heat generation can cause the insulation to melt. Thereby we can conclude that we are actually measuring the amount of leakage current flowing through the leakage insulation to the earth. This is the actual meaning and definition of the insulation resistance. Suppose this is our conductor and this is my wires and the conducting wires through which the current is being flowing. This is a normal case, but we are going to discuss what will happen in case a crack or some breakage or some melting of the insulation occurs. Then what will happen? Instead of the current which is flowing here, some amount of the current will leak from this insulation and ultimately passing over to the ground. You can see that if I am having a breakage or there is some leakage in the or crack in the winding, then the current will leak and will find a short path and it will easily try to go to the earth, which is have at the low potential. So we are actually going to measure the leakage current, the amount of the leakage current. Then we will be able to find what is the insulation resistance. Okay, so this is how we are going to proceed. And how we are going to test? We are going to put the insulation resistance testing meter between the line which is conducting and to the insulation which is earth. So we are going to put a insulation testing machine between these two terminals through which we can find out how to get the insulation resistance. So far we have just now understood what is the basic concept of insulation resistance. Okay. Now to understand insulation testing, there is one simple equation. We are very much aware of that. That is Ohm's law. And it can be very much helpful in understanding many aspects. You can see here that this is the normal channel or pipeline where this guy is ampere, and this guy is voltage, and the person who is taking care of this process is ohm. Okay, so this is a very funny cartoon, but we can easily understand that this voltage is actually pushing, it is actually it is EMF, and it is electromotive force, it is forcing the current to pass through this channel. Okay, but because of the resistance which is put by the ohm here, this ohm is not a good person. Okay, he is making the ampere to get trapped in the resistance. Okay, so the volt is pushing the ampere, but because of the resistance the ampere is not able to pass out. That is why this is the basic fundamental which we are going to test and which we are going to use in the testing. Okay, and so far we also know that the common sense that more the voltage we have, the more current will be there. Okay, also if the resistance of the wire is low, then the more current will be there for the same voltage. Very simple. And this equation we are also very much aware that V is equal to IR, where E is the volt, current is in the ampere, and resistance is in the ohm. Okay, next, the purpose of insulation around a conductor is similar like of carrying a pipeline carrying water, and the Ohm's law of electricity can be easily understood if we are comparing with the water flow. You can see here, this is the pipeline, and there is a pump, and if the pipe is having a leak, then you will waste the water and we will waste some water pressure. All right, similarly in electricity, the voltage is like a pump causing the electricity to flow in the copper wire and the channel. Okay, if there is some resistance, then there will be less amount of the current flowing through the insulation. Okay, like this is my pump which is driving the water through this channel. Similarly, the motive force here is voltage, which is driving the current through this conductor and insulation. Okay, here the pump is same as voltage, the pipe is same as your insulation, the conducting medium is your water here, which is here is current. All right, and the friction is there, which is here is resistance. And if there is some leak in this pipeline or in this pipe, there will be leakage of water here, and we will be losing water. And if there is some leak or there is some crack in the insulation, then we will have what? We will be having leakage of the current. Correct. So this is the analogy which we are going to understand better while we are going to proceed for the insulation testing. Now the question arises, what is a good insulation? Some say there is a good insulation, there is a bad insulation. What is the meaning of good insulation? It means it is having a relatively high resistance to current. That means the good means the ability to keep a high resistance. So the suitable way of measuring resistance, it will tell us that how good the insulation is. So we are actually going to judge about the insulation quality, whether it is good, whether it is holding the current to avoiding the current to go outside. That is the main purpose of insulation, correct? Then what is making the insulation bad? We are saying that insulation is good, it is preventing the current out, but whenever our system is new, then the insulation is also very new, very perfect, very much intact. There is no leakage, absolute perfect conditions are there. But by that time there may be mechanical damage, there may be vibrations, there may be heat loss, there may be heat or cold or dirt, oil, corrosive nature, moisture from the around, and humidity on a muggy day. So in various degrees and all these factors, these are the enemies. These are not good things for any machinery or any windings. So at this time there will be electrical stresses over the cabling. So there can be pinholes, there can be crack provocation, there can be cracks of the winding and the insulation. So what will happen? The current will say, okay, I am finding a very good low resistance path for my flowing. I will follow this leakage path. Okay, that is why it will cause less current flow and it will leak over from here. Thereby insulation resistance will be bad. So how the insulation resistance is being measured? You have seen that the good insulation has high resistance, just now we discussed, and the poor insulation, which is bad insulation, has low resistance. Because of the least resistance path, the current will leak out. But actual resistance values can be higher or lower depending upon the factors also. There may be temperature factors or the moisture factors. Okay, so the resistance will decrease in case of the temperature of or moisture. Here comes the introduction of the Megger. The Megger was actually, it is a registered trademark product which was introduced in some 1900s, and the name was changed from megohmmeter to Megger, just for the sake of ease of speaking. The Megger insulation tester is a small portable instrument that gives you the direct reading of insulation resistance in ohms or megohms. For the good insulation which we want in our ship engines and ship systems, the resistance usually reads in megohm range, and the Megger insulator resistance is essentially a high range resistor meter with a built-in current generator, direct current generator, that is DC generator. This meter is of a special construction with both current and voltage coils, enabling the true ohms to be read directly independent of the actual voltage applied. And this method of DC generation is non-destructive. That means it does not cause deterioration of the insulation. It does not damage. It is safe. Why it is safe we will discuss, but just now we are seeing that here there is a hand crank shown on the Megger, and the voltage is generated in the generator by the DC generator. And if we see inside, then there is a clutch, there is a crank handle, and there is a DC generator which is producing the DC voltage across the testing terminals, and through the coil A and coil B the pointer will be showing the insulation resistance value from infinity to 0 as per the measurement of the terminals across the machinery. Whatever machinery we are going to test or any insulation, it will be shown across these meter. So the DC generator can be hand cranked or the line operated to develop a high DC voltage which cause a small current through and over surfaces of the insulation being tested. And this current may be usually at applied voltage of 400 volts or more and is measured by ohmmeter, which is having a indicating scale. So this is how a typical scale of the ohmmeter looks like, and it ranges from, and you can see here there are two scales, megohms and ohms, and the voltage applied and the corresponding infinite or the zero values and the values being ranged. And this is the Megger, which is showing some insulation testing and which we are going to discuss in next slides. So how to make the connections for the testing insulation resistance? Okay, so the connections for testing insulation resistance of a power cable, let's suppose we are taking first example power cable. So when testing the cable, it is usually best to disconnect at the both ends in order to test the cable by itself, thereby avoiding error due to leakage across or through the switchboards or panel. Okay, suppose this is there are 3 windings inside, 3 cable core, and we want to check the insulation of this cable, this conductor. What we will do, we will connect this end to the line, okay, and the other conductors which we are not going to test, we are going to make it earth, and because of the leakage we are going to connect it to the ground, which is already ground, and we are going to connect it to the earth, and thereafter we are going to crank it, or maybe there may be internal DC generator. So we are going to see the insulation resistance value over here. So this is how we are going to make the connections for the testing IR value. Next, suppose there are many other conductors. So what we are going to do? The same, we are going to short the wires and the conductors which we are not going to test, and we are going to make it common. Okay, this is common and this is going to the earth, and we are connecting this part to the earth terminal, and the conductor which we are going to test, we are going to connect it to the line. Okay. Similarly, in case of motor IR value testing or any other like this, we are going to check the main switch IR value, or we are going to check the brushes or commutator of a DC motor. Similarly, the lines we are going to check, we have to connect to the line L live, and the other main body we are going to connect to the earth and make it ground. Similarly here also, earth and the ground. This is a basic connection for testing IR value. Next, we are going to discuss about the guard terminal. Many people think that there are only two terminals in a Megger, that is line L and earth E. This is agreed, okay, acceptable, because we are using two terminals. But one thing which people usually do not notice, that the Megger contains another third terminal, also known as guard terminal G. Okay, you can see here the third terminal also, guard terminal written G. So what is this guard terminal? We are going to discuss now. Suppose there are dusty or there are some oily environment conditions which are put here, and the virus, this conductor or the insulation is bound by these dusty oily surface conditions. Then what will happen? There may be chances that suppose we are going to test this conductor, but other conductors may leak, current may leak out, and it may give the wrong insulation resistance value. There are many more chances that because of these environmental conditions, there may be wrong insulation resistance value noticed because of the influence of other conductors. Okay, because of the leakage, superficial leakage, current leakage by the, because this dust and oil are also conducting material. So we are going to check this insulation resistance, but because of the dust, this is making another leakage current, so there may be wrong value. So what will happen? So what we are going to do, we are actually suppose we are going to check the IR value of this terminal B. Okay, we are connecting this IR value B, and we are making the insulation with earth E, but we are going to connect the terminal A to the guard connection G. What benefit this guard connection is going to make is that there will not be influence, or there will not be interruption of the A terminal on the measurement of B IR value, because when the A will be connected to the guard terminal, then the current or any leakage current, if any leakage current is there in conductor A, it will leak through the least resistance path and it will circulate in the same line. Okay, it will not influence or it will not interfere in this value. This is the main circuit for the conductor B and the insulation, which is sheath. Okay, this insulation we want to measure, correct, but we do not want the insulation to go here also. So what we are doing, we are actually making this A conductor to connect to guard terminal, so that it will be always bypassing this effect, and only B insulation resistance will be measured. So you can see here also the guard terminal is being connected to the superficial leakage current, and it is actually not interfering. So we are getting the true value of the IR. I hope this guard connection is understood well. So you can see here, after we are putting the GAR terminal, we are going to wrap the conductors which are not of use to us, because there may be dusty conditions over this braid, and braided wire and other conductors may cause the IR value to go wrong. So we are going to check only this conductor, and we are going to make the surface any leakage current, we will be going to the guard, and it will be circulating in the circuit. Okay. Now the factors affecting the insulation resistance readings. So there are many other things which are affecting, like temperature, insulation, humidity, leakage current, and there may be IR value should be approximately 1 megohm for each 1000 volts of operating voltage, with a minimum value of 1 megohm, which is a safe value. Now, uh, before going for the testing of IR, if the equipment is wet, suppose the equipment is wet and from the fresh water, or then you have to make it dry. And suppose you have got sea water or salt water, then you must first wash away the salt with the fresh water. Otherwise, you may cause the corrosive deposits of salt on the metal and insulation surfaces. This is the uh, crevices which may form in the insulation, and the salt deposit can cause uh, insulation to go bad. So what will happen, such deposits will be forming as a good conductor of electricity. So we should remove the oil grease from the insulation using a suitable solvent. And before testing, the apparatus or the machinery should be isolated, and it should not be live. And this is the AC equipment rating and the DC test voltage up to 100 volts. Your DC test volt is 250 volts to 100 volts, and by the time your AC rating is increasing, your DC test voltage is also increasing. And this range we are normally using on board ship, because our ship systems are 440 volts, and our DC test voltage is lying between 500 volts to 1000 volts. Also, the test voltage for proof testing of the equipments are considerably higher than those use of routine maintenance. So this value is always higher than the AC rating. Now, up to now we have talked about the testing of DC voltage, but there may be some question that why not we are considering AC testing. So if we are testing with AC, of course we can, but the AC will give a charging current that is extremely high as compared to the other kinds. So the leakage current is relatively minor. It will not be helpful in detecting the leakage. So AC frequently is used for high potential testing, and the voltage is increased to some specific point to see if the insulation can withstand that particular voltage. So also AC can cause deterioration of the insulation, but the DC test, it is always non-destructive, because DC is a steady voltage over AC testing. Some of the advantages for the DC test sets are that they are of low cost, they are light in weight, they are smaller in size, they are non-destructive, and they are better information in both quality and quantity. Lastly, the effect of temperature on the insulation resistance, that we have to always keep the temperature around our gadgets and our machinery not too hot and not too cold, because for every 10-degree rise in temperature, the IR value will be half, and for every 10-degree decrease in temperature, the IR value will be doubled. So we have to keep the temperature monitoring also nearby our electrical equipments for the healthiness of the system. I hope this discussion on the insulation resistance, how the Megger works, and what are the terminals, how the leakage current happens, and is well understood by all of us. And before surveyor or any person on board ship or any other electrical equipment which we are going to test, we are confident enough that yes, the Megger is used by this method, and we are going to make the connections. And if you have understood this video very well, and if you appreciate this, please subscribe to this channel, because this channel is very much this is dedicated to our fellow seafarer, and especially all the electrical engineers and other engineers. So please subscribe to this channel, and take care and bon voyage. Thank you so much.